Similar triangles in trigonometry. Recall that Thales found the height of the pyramid by using similar triangles created by the shadow of the pyramid and a rod of known length. But what if you were trying to solve this problem and there wasn't a shadow to use? Or what if you were trying to solve other types of problems which don't allow you to set up a similar triangle so easily? Trigonometry provides the needed similar triangle for any circumstance, which is why it is such a powerful tool. If Thales had used trigonometry to solve his problem, he'd have considered the right triangle shown below. First, he'd measure the angle labeled theta, the angle between the ground and the top of the pyramid, when at a certain distance away on the ground. Then, he would imagine a similar triangle with the same angle. He has a ready-made right triangle thanks to mathematicians who calculated all of the possible right triangles that could be created with a hypotenuse of 1 and put their measurements in a table, a trigonometry table. The side opposite the angle is named sine theta, or sine theta for short, and the side adjacent to the angle is called cosine theta, or cosine theta. We know all the angles are equal since both triangles include a right angle and the angle theta, so those two angles are the same in both triangles. And since all the angles of a triangle total to 180 degrees, all three angles must be equal. Since all the angles are equal, the triangles are similar. Since all the angles are equal, the sides are proportional. So what would this ratio be equal to in the triangle to the right? So height over distance would be height over distance. So that is sine over cosine, because we have sine here and cosine here. When we did the problem earlier, we used the rod's height of 1 meter and its shadow length of 2 meters. That would mean that the angle between the rays of sunlight and the ground would have been 26.6 degrees, and the length of the pyramid's shadow was 120 meters. Let's use that angle and distance and see if we get the same answer. If the distance was 120 meters and the angle was 26.6 degrees, you find the height by solving for it, and then using your calculator to look up the values for sine and cosine of 26.6 degrees. So here we're looking for the height, so we input in the distance and 26.6 instead of theta here. So we get height over 120 meters equals sine of 26.6 degrees over cosine of 26.6 degrees. So if we look up those values in your calculator, the sine of 26.6 degrees is 0.448 and the cosine is 0.894. So we multiply that by 120 meters and we get 60 meters. Tangent theta. Early in the last problem, we found that height over distance equals sine theta over cosine theta. This ratio of sine to cosine is used very often and has its own name, tangent theta, or tan theta for short. Tangent theta is defined to be sine theta divided by cosine theta. Tangent theta equals sine theta over cosine theta. The last step of that problem required finding the values of the sine and the cosine of 26.6 degrees. When working with trigonometry, you'll need to find the values of sine, cosine, and other trig functions when given an angle. This used to involve using tables, but now it's pretty simple to use a basic scientific calculator. Basic scientific calculators are available on computers, tablets, and smartphones. They can also be a separate device, similar to the inexpensive calculator shown here. It can do everything that you'll need for this course. The trig functions we're going to be using right now are sine, cosine, and tangent. Those are marked in the box on the calculator. So here's sine, cosine, and tangent. On most calculators, they are noted by buttons which say sine, cosine, and tangent. This button here that says SIN, that's for finding the sine of an angle. This button right here that says COS is for finding the cosine of an angle. And this button here that says TAN, or tan, is for finding the tangent of an angle.